form, you start right away at your y-intercept. For example, if I say you have y equals negative 2/3 x minus 3. Is that equation in slope-intercept form? Yeah. Okay. What's your y? Or first of all, where's your y-axis? Is it the left and right or the up and down?
Oh, I'm right.
Down. The up and down. Okay. You guys know that. Okay. So your y values go up and down. So what's the y-intercept here? Negative 3. Remember, always grab the sign that's in front of it, whether it's a positive or a negative. So you would start at negative 3. So you go to the intersection of the origin, go down to negative 3, make a dot. What's your slope? Okay. Whoa. Remember yesterday when we talked about slopes? Your slopes, your first step is rise over run. So your first step is always to go up or down. This is negative, so which way am I going to go first? How many? 2. And then which way? How many? 3. Good. So your slopes, remember, you always go up or down first, then left or right. Well, actually, I should say always go right. So we're going to go up or down for being positive or negative, and then always go to your right. And you do it a couple of times. Down 2. What I like to do with these, I like to fill up my graph. Now remember, the opposite of, I'll get you in a second. The opposite of down and right is what? Do the same thing. Up 2, left 3. And then just connect them out. Yes, ma'am. Correct. Yes, that is absolutely correct. And I was going to show that example like that next because not always are numbers written as fractions. Okay, and you guys know that. Not always numbers are written as fractions. And like she was saying, sometimes if I get 3x plus 1. And if I have the equation y equals 3x plus 1, remember, you can divide anything by 1 and it doesn't change it. Same thing goes that, what's the coefficient of x that you just don't see? A 1. They just don't put it there. Okay, they're saving ink as they're printing out books. All right, it's just a shorthand way of doing it. You don't have to write every number as 3 over 1, 4 over 1, 5 over 1. But anytime you've got a whole number, whether it's or an integer, whether it's 3 or negative 3, it's the same number over 1. Because you can divide anything by 1 and it's still itself. So where do you start this one? 1. That's a bad example, keep using the number 1, but whatever. So you start at 1 and now you walk your slope. What's your slope? 3. So I go up or down? Up 3 and then which direction? 1, 2, 3. Oops. And then the opposite of up and right is, oops, wrong spot. Down and left. And you're done. Okay. Drawing graphs of lines really is very, very simple. Okay. It's writing the equation that sucks. That's what's not. Graphing is the easy thing. Okay. Graphing is the really easy thing. Now, the one thing that I do know for certain that most of you guys will always mess up is the difference between a horizontal versus a vertical line. And this is where I want to make sure you guys get some good examples of. When we dealt with our slopes yesterday, and just when we were just talking a minute ago about y equals 3 or x equals 5, when we're dealing with slopes of those lines, we knew that the horizontal line always had a slope of what? 0, because what's the second letter in horizontal? Okay, dumb way to remember, but it works. Horizontal lines have a slope of 0. Always, always, always. Vertical lines always have a slope of horizontal is 0. So what's vertical? Remember,
In order to get a slope of 0 for a horizontal, that means you had 0 in the numerator and some number in the denominator. Correct, because it's flopped. It's flipped, excuse me. Vertical is undefined, and that was the question you had with me earlier. You had 5 minus 5 in the denominator. So what happens here is that vertical lines have a 0 in the denominator and some number in the numerator. Now, as you know, you cannot divide by 0. It's just bad things happen. Things explode. I'll show you an example of that later. When you have that, I want you to think about just looking at a graph. Let's move this for a second. If I just kind of rough sketch in a horizontal line, and I know it's kind of overly done here. If I draw that horizontal line, what number did that horizontal line go through on the y-axis? 1, 2, -3, you'd say? I'm going to say it's -3. So it went through, oops, it's out here. It went through -3. What value never changes? What never changes? The -3. What's the -3 here? What is it, the x or the y value? It's the y-intercept. It's the y value. The y value at every single one of these points, all the way through, is always going to be -3. The x values change. The x values will change, but the y value stays constant. So that means that whenever you have a horizontal line, it's always going to be y equals a number. Your y equals a number is the equation of every single horizontal line. Y equals a number. No x's, no nothing, just some number. That number is where that graph goes through the y-intercept. Right? On the other hand, when you have a vertical line, what never changes? The x value. The x value never changes when you have a vertical line. Okay? So if you're looking at where the vertical lines go, see if I can move this on here. This vertical line went through, what, 6? That x value 6 remains constant, stays the same, all the way infinitely up and down. It's always going to be 6, 2, 6, 3, 6, 4, and so on, or 6, -143. It doesn't matter. That 6 value remains constant. That means that anytime you have a vertical line, it's always going to be x equals a number. Okay? X equals a number. X equals a number is always a vertical line. Y equals a number is always a horizontal line. Adios. Okay? That never changes. Now, when you look at those, and we'll get more into this on Monday, what's the relationship between horizontal lines and vertical lines? What are they to each other? You're on the right track, but yes, they're perpendicular. If you look at your lined paper, and all these horizontal lines going left and right, don't you? All those blue lines are all horizontal. That tab line, that red line, it's vertical, isn't it? Isn't that vertical line perpendicular to every single one of these lines going through here? Isn't every one of these horizontal lines parallel to each one of these other horizontal lines? If you kind of see it off on the left hand or the right hand side, there's that real faint red tab. Isn't that yeah, and that's where we're getting into more. Sorry, that was good. That's where we're gonna get more into the parallel and perpendicular stuff next week. Okay, but today all I want us to do is kind of revisit horizontal, vertical, and how we ground it. Okay. So I didn't want to like jam all that into one day. So, guys, yes. Oh, no, wind is made by air pressure changes.
Condensation is not in biology.
Yes, it is. We were just like that.
Oh, really? Oh, yeah, you're right. Yeah, I forgot about that. It's only been a few years since I've had to do that. So let's do this. No. I do use that for like I should have hole punched it for you guys and throw it in your notes. I just wanted to have you guys do a couple examples of how to graph because I knew you remembered how. It's just one of those things. Knock this out. Real quick, if you slip over to numbers 7, 8, 9, and 10. Yeah, everybody's is kind of the same on that one, but they're a little different. It's asking you to write the equation of the line. So if it says write the equation of the line, I'm going to see if I can get this one to work. As I'm looking at it, I have one here that looks like it has a y-intercept. It goes up 1. My line looks kind of like this. What you want to do here, as you look at those graphs, try to identify what the y-intercept is. And the one that I'm looking at, my y-intercept is at 1. So I know my b value is 1. I also know that if I walk my graph, if I go up and right, I go up 1, right 3, what's my slope? Other way around. Yeah. Remember, rise up 1, or excuse me. You were right, 1 over 3. I said 3 over 1. I'm sorry, forgive me. I'm sorry. I didn't pour some more coffee. You were correct. So your slope then would be 1/3. Put them together, you get y equals 1/3 x plus 1. I didn't think you guys would have a problem with that. We just hadn't done an example. Very similar to all the rest of them. So then you've got those. We have 2 through a point. You know what? Cross off the last 2 of the whole. Cross off your 19 and 20. You don't need to do 6 of those. Then we just do 4 though. We got the 6 graphs, real easy. 4 write the equation, 4 write the equation, then 4 write the equation. So you've got what? Half an hour to knock out 18 of these? Come on now. Knock it out. Yes, sir. Absolutely, man. Absolutely. Try some of the graph ones first, and I'll probably go help it out after I get some of these papers back. All right. Sound like a deal? You guys want to listen to your minutes required unit? That's fine.